Good morning, good evening, and good afternoon. Wait, that didn't sound quite right. Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we are doing another crazy video here because I got tons of time on my hand just to do crazy videos. Actually, not really. I just came here really late, and so we need to finish up these videos. Please, before you watch this video, you need to make sure that you watch the first video of this series, Electron Configurations and Orbital Box Diagrams, worksheet number 1. That's right, folks. And on that one, I described exactly how we labeled the periodic table. So I'm going to pop this up here because we have used this already before in the previous video. And I'll just give a quick little summary of this. So let me see if I can zoom on out here. This is critical to understanding what we are going to be doing today on today's video. So just a real quick summary. I've labeled up this periodic table like I labeled it up before, and I'm going to do it again, folks. That's right. That's why I'm here. So what I've done is I have labeled in the pink here the S-type orbitals, in the green, the P-type orbitals, in the blue, the D-type orbitals, and in the orange, the F-type orbitals. That's sharp, principal, diffuse, and fundamental, folks. That's right. In the green circles on the far left-hand side and within the D's and F's, I have the floor level or the really the principal quantum numbers, really what it's called. That's 1, 2, 3, 4, 5, 6, and 7. For the S's and the P's, they stay with these numbers. The D's are 1 less, as you can see, this is a 3D, and even though it's in period 4. The F's are 2 less than the period or 1 less than the D's. On the far right-hand side, in yellow, I have labeled all the noble gases. That's correct. Then at the very top, I have in red, I have 1, 2, 3, 4, 5, 6, 7, and 8 scratching out helium. I have the number of valence electrons in these columns. So if I have polonium, how many valence electrons? 6. If I have tin, how many valence electrons? 4. If I have gallium, how many valence electrons? 3. Exactly. Now, the other set of valence electrons is if that element ends in the D or the F section, you have seen that I have drawn a red cowboy boot here. Not a very good cowboy boot. I do understand that. My drawings are pretty poor, but hey, I'm a chemistry teacher, not an artist here. So excuse and apologize for that. So I have this red boot. And this red boot, how many boots would you wear? You would wear 2. So if you are in the D's or the F's, then that's right, folks. You have 2 valence electrons. Perfect. I'm going to do a little bit of folding on the periodic table here as well. And that is, what grade do you not want to get in your chemistry class? That's right, an F. So let's fold out the F's. What other grade do you see here that you don't want to get in your chemistry class? That's right, a D. So what are you left with? Satisfactory passing grades in your chemistry class. Now, that only happens if you are actually working hard and studying. That's the only way to get satisfactory passing grades is if you work hard and study. So now you should see that these numbers, these principal quantum numbers, the floor levels on the far left-hand side that are circled in green do correspond to the S's and P's. So this is period 2. This is period 4. This is period 5, period 7, for example. All right. So without further ado, let's continue on. We're going to unfold our periodic table here just for a little bit, okay? And we are going to start working on these problems, okay? So the last set of problems on the first worksheet, I did the elements that are highlighted in yellow. So we might as well do some highlighting of another color. What color would you like? I'm not hearing anything. Okay. Oh, I got it. I got it. It's green. So we're doing green. Thank you very much. I appreciate your participation. All right. So with green highlighted, so what we're going to do is we are going to zoom on in here just like that. Perfect. And I am going to find element number 3. It's an Li. It is lithium. So I'm going to find element number 3. I'm going to fold my periodic table here very nicely, so that we can see just sections of it, because that's really what we're interested in here right now at this moment in time. Let's zoom on out just a hair so we can see almost, nope, let's do it. Let's do it all right. There we go. Perfect. There we go. So where is lithium? It is element number 3. That's Li, and that's for lithium. So I need to do lithium. So we're going to do the electron configuration and orbital box diagram and valence electrons for lithium. So just like before, we're going to find lithium where it is, the element of choice. Then we're going to go up one period, up one floor, slam it to the far right, and we're going to write down helium. That is going to be our noble gas that we're using. That is He. That is in brackets, just like before. And when we do that, we have counted up to 2. We actually need to count only up to 3. So that is a 2S1. That's all we're going to write. 2S1. And then we're going to simulate this same thing in our noble gas notation of an orbital box diagram. That's helium, and then this is a 2S, and that is a single up arrow, just like that. Now, to get the valence electrons, I'm going to look on my periodic table, and I'm going to find the red number on the top of that column, which is the group, and that is a 1. So the number of valence electrons in lithium is 1. And just like before, it's the largest principal quantum number, and there's my 1. Perfect. I'm hoping that you're, giving yourself a pat on the back and applause or something like that. That would be a good thing. All right. Fantastic. Let's do the next one. I just had a little bit of sip of some decaffeinated coffee. You imagine if I had caffeinated coffee, I would be able to speak so quickly, you would not be able to actually follow me along, sadly. So that's why we're doing decaffeinated coffee. The next one is element number 6. That's a capital C, and that is for the element of carbon. So I'm going to find element number 6 on my periodic table. That's right there. That's capital C, and that is most certainly carbon. So I'm going to do the electron configuration for carbon. So what are we going to do? We're going to find carbon, and we're going to go up one floor, slam it to the far right. We got helium. So we're going to write the noble gas here of He. That's helium in brackets perfectly, just like that. I've counted up to 2. I'm going to do 3, 4, 5, and 6. It is floor 2, it's an S, and it's 1 and 2. And remember, just like on the previous video, there is a break in our periodic table. So it's 2S12. I'm going to write that down. 2S2. And then it's going to be 2, because it's in the same floor, 2, P12. And I'm going to end right there with that. So that will be 2P2. Okay. I know I have that at a slight angle, so I apologize for that. Let's see if we can straighten that up just a little bit here. Okay, there we go. All right, now we're going to do the orbital box diagram of the same thing. We got helium in the brackets, and then we are going to label this. We have a 2S, we have a 2P, and then it's an up, it's a down, it's an up, and then it's an up, just like that. Number of valence electrons, largest principal quantum number, it's a 2 and a 2 and an S and a P, and it's a 2 plus a 2, that's going to be a 4, but I'm going to verify and validate that on my periodic table, and yes, if I find carbon, the number above it is a 4. That's perfect. Okay, everybody good? We got that one nailed. Let's do the next element here. So let's find the next element, and that next element is going to be oxygen, and that is element number 8, and that's capital O, that's for oxygen. So let's go on our periodic table and go for a hunt for oxygen. So that's element number 8, that's O for oxygen. Yay, good job, congratulations. So what we're going to do is we're going to find our element of choice. We're going to go up one period, slam it to the far right, that's He for helium. So that's what we're going to write here is He for helium. That's in brackets. And now what we need to do is we have counted up to 2. Now we need to do 3, 4, 5, 6, 7, and finally 8. So 3 and 4 are S-type orbitals. 5, 6, 7, and 8 are in P-type orbitals. So hopefully that makes sense because of the break in our periodic table if we folded this up correctly. So it's going to be a 2S12. I'm going to write that down. 2S2. Perfect. Then after that, since there's this break, but yet it's the same floor of 2, P, 1, 2, 3, 4. 2, P, 1, 2, 3, 4. So I'm going to write that down, 2, P, and 4. If I look on my periodic table, above oxygen is the red number 6. That's 6 valence electrons. 6 valence electrons, and I can verify that by the largest principal quantum number 2 and 2 and adding these two numbers up, 2 plus 4. I am going to do the orbital box diagram, and that's HE. This is a 2s, this is a 2p, and I'm going to go up, we're going to go down, we're going to go 1, a 2, a 3, and a 4. Perfect. We've just done oxygen's electron configuration using the noble gas notation, oxygen's orbital box diagram using the noble gas notation, and the total number of valence electrons. I want to make sure that you do not have this number 4 here or the number 2 there. That is incorrect. That is incorrect. So I'm going to scratch that out. It is just the energy level and the type of orbital of labeling our boxes correctly. All right, just making sure. The next one is going to be element number 10, which is Ne, which is neon. So this always causes students a little bit of an issue here. So I'm going to have to highlight this. We got neon right there like that. So what we cannot do is we can't just say Ne in brackets. I know you want to do that. It's like really fun, but no, that's not how we do it. Okay, so what we have to do, just like on anything else, just like on oxygen or carbon that we have done, or lithium that we have done, or on the previous video with fluorine, we go up one period and slam it to the far right. Well, it's already slammed to the far right, so we just go up one period. We're going to get helium. So we're going to write down helium in brackets there, just like that. Okay, we've counted up to 2. Now we need to do 3, 4, 5, 6, 7, 8, 9, and finally 10. So if I break my periodic table there like that, we can see that we're going to do 2s12. We're going to write that down. Then we're going to do 2p, 1, 2, 3, 4, 5, and finally 6. So it's 2s12, 2p, 1, 2, 3, 4, 5, 6. So let's write that down. 2s2, 2p6. Perfect. Now, how many valence electrons are there in neon? Look at the top. That's an 8. Absolutely, most certainly, that is an 8. I'm going to sum up the largest principal quantum 2 and 2 quantum number 2. That's a 2 and a 6. That's 8. Okay, we're going to write the orbital box diagram of the same. So we're just copying down essentially what we did with the electron configuration. That's helium. We have a 2s label, a 2p label of the energy level and type of orbital. That's an up, that's a down. 1, 2, 3, 4, 5, and 6 finally. Okay, that's diamagnetic, by the way. That's when we have all paired electrons. Something beyond the scope of this course, but we'll just let that ride and you think about that later on. All right, now what we're going to do is we are going to do the back side of this worksheet here. And the back side of this worksheet, the next element here is going to be magnesium. That's element number 12. That's Mg for magnesium. Let's find element number 12 on our periodic table. That's Mg for magnesium. Okay, perfect. So what we're going to do is once we find magnesium, we're going to go up one period, slam it to the far right. We're going to go neon as our noble gas. So that's Ne, that's in brackets. And that has counted up to 10. I'm going to do 11 and 12. So that's the third floor, S1 and 2. So 3s1, 2. And that's it. 3s2. All right, I'm going to do the same thing with the noble gas notation for the orbital box diagram. That's Ne. There's a 3s, and that's 1 and 2. Magnesium is in group 2. That is 2 valence electrons. You're going to write 2 valence electrons, and those 2 valence electrons are right there. Perfect. Awesome. Hey, by the way, what show are you watching right now? That's right. You are watching The Crazy Hat Chemist. There are no advertisements right now, right here, unless, you know, YouTube is placing them on there, but there's no advertisements here that I'm doing except for myself. So I'm crazy and I wear hats every Friday, by the way. If you were to take my class, you should take my class. It's a great class. If I do say so myself. All right. The next element here is aluminum. That's aluminum. That's element number 13. That is Al. So we're going to find element number 13 on the periodic table. That's the next element beyond magnesium there. So that's Al, aluminum. Perfect. Just found it. Piece of cake. Okay. So now what we're going to do is we are going to write the electron configuration for aluminum. Again, what we're going to do is we're going to go up and slam it to the far right. That is neon. So I'm going to write that down. That's element number 10. Then it's going to be a 11, 12, and 13. So that's 3s1, 2. Then there's that break in the periodic table, remember. Then it's 3p1. So that's what we're going to write. Neon, 3s1, 2, 3p1. So neon in brackets, 3s2, 3p1. I'm going to label this NE for neon, and it's a labeled of 3s, a 3p. This is an up, that's a down. This is a single up like that. Aluminum is in what column or group? It's in group or family 3. So that means that there are 3 valence electrons for aluminum. And it's the largest principal quantum number, and sum them up. Perfect. Done. Easy peasy. The next element that we're going to be doing here today is element number 15, and that is a capital P for phosphorus. Let's find that. Number 15, that's a P for phosphorus. We've found that element. Now what we're going to do, we're going to go up 1 floor, slam it to the far right. That's neon. Then it's going to be a 3s1, 2. Then it's going to be a 3p1, 2, 3. Okay, hopefully you got that. It's neon in brackets. Then it's going to be 3s1, 2. Then it's the break, remember, 3p1, 2, 3. Okay, how many valence electrons in phosphorus? 5. All right, so let's see if we can write all that down here. That would be neon in brackets. That's 3s2, 3p3. There are 5 valence electrons. I should be able to count up those 2 numbers right there. That's neon in brackets there. This is a 3s. This is a 3p. This is an up. That's a down. This is an up and an up and an up. All right. Congratulations. You're doing very good. All right. The next element here that we're going to do is element number 21. So you finally reach the age of 21. That's SC for scandium. So I need to find scandium on my periodic table. And I see 19 and 20 and then 31. So that means I need to open up my periodic table here so that we can see element 21. So I'm going to zoom on out here for just a little bit so that you can see this and all in one spot. So it's kind of important that we get all of this here a little bit flat, a little bit good. There we go. Perfect. So element number 21 is right here. That's SC for scandium. All right. So what we need to do is we need to go up 1 period. That's 1 floor up and slam it to the far right. So that's scandium. We're going to go up 1 floor, going to the far right. That's argon. So we're going to write argon. That's element number 18. Then we're going to do 19, 20, and 21. 19 and 20 are S. 21 is a D. So 19 and 20 is a 4S, 4S1, 2. Then we have a 3. See that 3 there? It's a 3 and a D. 3D1. So it's argon, 4s2, 3d1. Let's write that down. Argon, 4s2, 3d1. Perfect. That's argon, 4s, 3d, 4s1, 2, 3d1. Number of valence electrons. Just so happens that scandium is in the boot. Let me show you the full boot here so that you get it, or at least the partial full boot. There's the full boot. If you end in a D or an F, which scandium is ending in a D, it has 2 valence electrons. So that's why I'm going to place a 2 here. And again, if you are writing this down correctly, it's the largest principal quantum number. That's a 4, and it's that 2, not that 3. Excuse me. All right. Are you hanging on? I hope you are, because we only have one more problem to do. So don't let go. Hold on tight, folks. Okay, the next element is gallium. That's number 31. That's Ga for gallium. So let's find gallium on the periodic table. I'm going to do a little bit of folding so that we can see the vast majority of this, put a little bit of weight on this so we can put it down. And where is gallium? Well, it's number 31, so that shouldn't be too hard. There's 31. That's Ga for gallium. Perfect. So this shouldn't be too hard. We're going to find gallium number 31. We're going to go up one floor, one period, and then we're going to slam it to the far right. That's going to be argon. That's number 18. Then we need to do 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and finally 31. Now, I want you to notice that we're going to write down argon. Then it's going to be floor level 4. S. So 4s, 1, 2. Then it's 3d. 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then finally, it's going to be 4p1. Okay, so did you see that there? I'm going to do that one more time since it's the last one. It's argon as the noble gas because it's one group, one period up, one floor up. It's going to be argon. Then it's 4s, 1, 2. Then it's 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then finally, 4p1. All right, that is what we're going to write. Sorry for that phone call, folks, but you know, chemistry talks. So here we go. So let's keep on going with our gallium and making sure that we got this correct. So we're going to do argon, 4s12. Open this up. 3d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then finally, 4p1. Let's write that down. So we got that argon in brackets. Then it's 4s2, 3d10, and then finally 4p1. So that's argon, and that's a 4s, it's a 3d, and it's a 4p. And we can look at the valence electrons here on gallium, and that would be 3. And that's why, if you look at this right over here, this is a 3, and it's the 4s, and I'm going to add up that 2 and that 1. Perfect. And then I'm going to put my electrons here in my orbital box diagram. This is an up, that's a down, and this is 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10. And then at 4p1, that's an up. And let's tie this up really quickly here. We're going to just give a quick review of our periodic table and then what we have done here today. So let's zoom on out. Let's put a little bit of weight on here so we can nail this down, so to speak. So just a real quick little summary here. We got S's, we got P's, we got D's, and we got F's. We got periods 1 through 7. The D's are 1 less than that. The F's we haven't even touched upon yet, but that's okay. All right. And the valence electrons are in red at the top. That's 1 through 8. And then if you're in the boot, that's a D and an F, and you would have 2 valence electrons. Okay, this is the second worksheet of 2, and I have highlighted in yellow the elements that are on the first worksheet. I've highlighted in green the elements of this video. So I want you to see that we are starting to fill this out. We have a couple more worksheets to do, a couple more videos to finalize as well. So if you are learning chemistry here with me, and I greatly appreciate it, whether in class or through this video here series, then please give me a like and please subscribe. I'm going to throw out these worksheets and the answers here so that you can see this as a quick little summary. You might need to take a screenshot of that. And then here is the back side of that. Let's zoom on out just a little bit more so that we've got it all. Wait, can we get it all in there? We got it all in there. There we go. Fantastic. Again, I am the Crazy Hat Chemist, and I greatly appreciate your time and watching these videos, and hopefully they're short enough, but yet you learn what you need to learn, and this is most certainly chemistry. Have a fantastic morning, afternoon, or evening, and I'll see you next time. Bye for now.